So what we're going to do now is we're going to use the quadratic formula to solve our equations, but our equations need to be in a quadratic form. That means they need to equal to 0. So I'm going to go ahead and switch this to equal to 0 by minusing the 11. Once we do that, we can identify our a, which is 1, our b, which is negative 10, and our c, which is a negative 11. Once you identify your a, b, and c, we can then use the quadratic formula up here to solve. So to solve, I'm going to go x equals in negative b, so it's a negative of a negative 10, plus minus the square root of b, which is negative 10 squared, minus 4 times a, which is 1, and c, which is negative 11. And that's all going to be divided by 2 times a, which is a 1. So if you just take your calculator and go through this problem, we go through this problem and clean this up. This is a positive 10. This is going to be a plus minus, and if you do the math in here, that's going to be 144 and over 2. So we could then simplify this. This is going to be 10 plus minus 12 over 2. So we now can just go ahead and solve that. 10 plus 12 divided by 2, and 10 minus 12 divided by 2. And the first one would be 22 is 11, and this would be a negative 1. So our answers become 11 and negative 1 based off using the quadratic formula. All right, so let's do another quadratic formula one where our answers will only have one answer. So let's go through how that looks. So the first thing we need to do is identify our a, which is 1, our b, which is 8, and our c, which is 16. So now I can do the quadratic formula. X equals a negative 8 plus minus the square root of 8 squared minus 4 times 1 times 16, all over 2 times 1. So then if we just do the math of that, we're going to get 64, let me see, 16 times 4. 16 times 4 is 16 times 4 is 64. So what happens is we have a negative 8 plus or minus in the square root of 64 minus 64, which is 0, over 2. So there's no radicals, so all we have is x equals negative 8 over 2, which is negative 4. So there's no plus or minus because there's nothing to add. So we just have one solution when we do that type of problem. Okay, sometimes we have solutions where we'll have irrational roots. So let's go through what that looks like. And once again, let's identify our a, which is 2, our b, which is 6, and our c, which is negative 7. So now I can go x equals a negative b, so negative 6 plus minus the square root of negative 6 squared minus 4 times 2 times negative 7, all over 2 times 2. So let's go through the math of what's in the quadratic equation. So that's 36 plus 56, 36 plus 56, 36 plus 56, 92, this is 56, and this is 36 over 4. So inside the radical sign, we have 92. Well, 92 is not a perfect square, so it'll come out as a decimal, and so we would have an irrational. And you can leave this, if it's not a perfect square, you can leave it in radical form. And there's our two answers for that. All right, our last type is when we have a complex roots, which means we're going to get some kind of negative in the radical sign. So let's go through that process. First, this one is not in quadratic form, so I'm going to go ahead and get it in quadratic form first by adding the 10 equals 0. So my a equals 1, my b equals negative 6, and my c equals 10. So x equals a negative of 6 plus minus square root of negative 6 squared minus 4 times 1 times 10, all over 2 times 1. Once again, we do the math. The negative 6 equals, hold on a second here, a positive 6. So we have 6 plus or minus. And if we do in kind of the square root sign, that's going to be 36 minus 40 all over 2. 36 minus 40 is a negative 4, so we have a negative 4 in our radical sign. And anytime you have a negative inside a radical, that radical has to change. We have to bring that out. So we have 6 plus to an I, and the 4 is a 2, so we'll have a 2I over 2. And there's our answer for a complex.